The naive approach to solve the sub-array sum problem would be to, well, look at every sub-array, keep finding its sum, and keep updating the maximum or the minimum, depending on what you're looking for. So what I mean is that, look, let's say I'm looking at a sub-array of size 3. So I start from the very left, start from index of 0. The first sub-array is this. Next, I look at the next sub-array, which is this. Next, I look at the next sub-array, which is this. I keep finding their sum. If I find that this sum is more than this sum, I update. And likewise, I can find out the maximum sum, or if needed, let's say the minimum sum. The idea remains exactly the same. Look at all the sub-arrays. Clearly, this approach will work because this is completely exhaustive. However, as we'll see, this is not very efficient, and which is why we are calling it the naive approach, a naive algorithm, which is just a starting point, but a correct starting point. Now, in order to write this code, well, basically we need a nested loop. So we need to keep track of the outer loop, which is basically the start of the subarray. So what I mean is, look, my outer loop is going to track where does the subarray start. So in this case, 0, 1, 2, and so on and so forth. And then I have this inner loop, which is going to find the actual, let's say, sum of that window. And this is of, let's say, length k, because notice the subarray is, say, k, which is in this case 3. So I find the sum of these 3, then I find the sum of these 3, then I find the sum of these 3, and so on. And I obviously keep updating the maximum value. Now, before we start to, let's say, write this code, let's just understand this a little bit more carefully. Why does JJ go in range n minus k plus 1? So, for example, if k is 3, then it's basically n minus 2. Well, the reason is this. Remember, the JJ is basically starting, is pointing to the start of the subarray, which means that the last subarray that I'm looking at must start at n minus k, which means the last value of jj must also be n minus k. Remember, the first value of jj is 0, then 1, then 2. The last value has to be n minus k, because remember there are k items in the subarray. So if since the very last item of the list is n minus 1, remember indexing starts on 0, so n minus 1 here. There has to be k items over here. Again, take some numbers which makes it easier. So for example, if k is 3, we are looking at n minus 3, n minus 2, n minus 1. So that's the 3 items. Last value has to be n minus k, and which is why jj must be in range n minus k plus 1. Now, having established jj, kk of course will be in range k, because we are looking at window of a subarray of, let's say, size 3. All right, so I get here to my Colab window. So I just go and say, well, let's define a function called max subarray sum. I use two arguments here, a list L and the value of the k, I mean the size of the subarray. The idea is that find the max subarray sum for all subarrays of length. Okay, so this is what we're trying to do. Now, since we are finding the max, I'm going to, let's say, start with a variable which we'll use to track the max, but I initialize that to a large negative value, and I can do that quite nicely by saying, well, let this be negative infinity. So it's basically a very large negative value that we are assigning it to. I am assigning a variable called jj max, which is going to keep track of where this window is. I assign it to 0, and then finally let's say n is length of L. So that's the length of the list. Now remember, we are going to run a nested loop. So I'll do that. I just go and say for jj in range n minus k plus 1. So we spoke about this, yn minus k plus 1. I say, well, current sum, say current sum is equal to 0. And then I just go and say, well, for kk in range k, so kk is going to be the inner variable, inner, let's say, counter, which is counting over the specific window. So that's of over range k, which is of length k. So I just go and say current sum is equal to, current sum plus L jj plus kk. Remember, the window starts at, or the subarray starts at jj, and then from there I do jj plus 0, jj plus 1, jj plus 2, jj plus k minus 1, which is a length of k items. Now, if I find that the sum of this window, so if the sum of this window, the current sum, is greater than the sum max, if this is the case, then I found a window which, let's say, a larger sum. So I can just go and say sum max is equal to cur sum, so which is the current sum. And I'll also record where did this happen. So that is my jj max, which is at jj. Remember, jj is the start of the window. Now, one thing very important here, this if statement must be outside the for, because look, the for loop here is finding the current sum over the window, and only after the sum has been fully formed would I want to make a comparison with the maximum sum. Hence the indentation here is important, but other than that it's fairly straightforward. I once I do this, once my loop is over, I can just go and say, well, return um, sum max and say jj max. Now we can test this. I can just go and say, well, let me call this function. So that is here. Let me just call this, say L. Let's say L is a list, say 1, 2, -4, say -4, 5. I'm just taking any list, 6, -8, 7, 1, 2, and say k is 3. If I want to do, well, x is, let's say, max sub array sum, L for a window of 3. Well, I can just say, then I can print, say, for example, max sum is x0, because remember, I'm returning the sum max first, at index, and that is x1. So let's run this and see. When I run this for the list that I've given, I get an answer that max sum is 10 at index 6. So that's basically 0, 1, 2, 3, 4, 5, 6. Sounds like it. 7 plus 1 plus 2 is indeed 10. Let's just test this by making this very, very large. Let's say I make it 40. So obviously the current sum, the maximum sum should come in this vicinity. Let's see what happens. Maximum sum is 51 at index 2. That is basically 40 plus 5 plus 6. So that is 51, and it's starting at 40, which is index 2, and that's exactly what we wanted it to return. So now this function basically is returning me the max sub array sum. It's also telling me where this sum happens, and hence it's solving the problem. But as we'll see later, this is rather naive an approach. We'll improve this with the sliding window approach to improve the complexity of this. I hope you found this interesting. Do look at our website www.ybyte.in. At Ybyte, we always learn programming in a systematic, step by step manner and forever enjoy coding. Take care. Thank you so much. Bye bye.